problem, maximizing productivity. So this is a problem if you want to be reminded of it. And then since you guys probably already read it, I'm just gonna give a quick summary. So Farmer John has n barns numbered 1 through n, and n is less than or equal to 2 times 10 to the fifth. And then we are given values called CI, which is the closing time of each barn. Bessie has to visit the barn before this time for it to count. Then there are given values called TI, which is the time between Bessie waking up and visiting barn I. Finally, we have Q queries from Bessie. These queries give us her wake-up time and how many barns she wants to visit. We output yes if she is able to visit the amount of barns she wants to, and no if she isn't. The amount of queries is less than or equal to 2 times 10 to the fifth. Okay, so some observations we have is that we must have an n log n solution or better. And we have to answer each query in O1, around O1. You technically can answer each query in log n, which is what some people did with binary search, but that isn't necessary for bronze, so I'm not going to be going over that. Okay, so since we have to answer it in O1, we want to make an array of answers. So so basically what we do is we do subtraction to know when Bessie needs to wake up to visit barn I. After that, if we sort it from greatest to least, the indexes will represent how many barns we can visit. Okay, so we can go over a sample test case with this. So this is a sample input. So if she wanted to visit barn 5, she can't visit barn 4. I mean, this first barn, because 3 is less than 4. But this barn, she's able to visit. So basically, she wakes up at time 2, she can visit it, because 5 minus 2, you have to subtract 1 after, because you have to make it strictly before. Have 5 minus 2 minus 1, which is 2. We have 7 minus 3 minus 1, which is 3. Have 9 minus 3 minus 1, which is 5. And we have 12 minus 8 minus 1, which is 3. So basically what these 4 numbers represent is if we sort them in from greatest to least, we have 5, 3, 3, 2. And these represent like how, like, if we get a number and then it's smaller than this, then she can visit 3 barns. Does that make sense? Thumbs up if it makes sense. Okay, I see a thumbs up. Okay, so basically if she said that, oh, I woke up at time 3 and then I want to visit 3 barns, it's okay because this is index 3 if it's 1 indexed. But if she said something like, oh, I'm gonna wake up at time 4 and I want to visit 3 barns. 4 is bigger than 3, so that doesn't work. Okay, let's move on to the code. So the first step of this code is implementing basically what I said. So this code, it makes sense, and it should pass like the official USACO problem, but it's actually a little bit wrong. So here we have, we get all the differences here, and then we sort it from greatest to least, and then if the answer of the index minus 1 is greater than or equal to the barn she wants to visit, we output yes, and if not, no. But this is actually wrong because there's some cases where it's like uh minus. So like it doesn't cover every single one because answer dot size is smaller than n. And then the actually correct code, which is a little modification, is this. So instead of just straight up sorting from greatest to least, we make a new answer array, and then we basically sort it from latest to greatest, but we do it like this. Does that make sense? Does anybody have any questions? Yeah, I'll send the code later in chat.